So this week we are going to kind of build on our factoring skills, starting with finding the greatest common factor and using that to factor out polynomials. So start by getting this definition down. Just copying it in our notes. Pause the screen if you need to. So the greatest common factor of two or more monomials is the product of all their common prime factors. Difficult to explain, very heavy on the math language, but you'll see how that works out in our first example. Before we go to that first example, though, let's remember how this shows up with just regular numbers. Okay? If I give you 8 and I give you 12, we can list out all the factors of both of those. 8 would be 1, 2, 4, and 8. 12 would be 1, 2, 3, 4, 6, and 12. And the biggest number in both of those lists is 4. That's our greatest common factor. Okay, it becomes a little more complicated when we're looking at monomials. Let's see how this shows up in our first example. So if I have 10x to the third power, what we want to do is we want to write out a list of factors, but we're going to write it as a multiplication problem. So this first one, 10x to the third power, I'm going to write it as 2 times 5 times x times x times x. Okay, 2 times 5 gives us 10, and x times x times x is just the expanded form of x to the third power. We do the same with 2x, but we can't really expand it out any further. We just get 2 times x. Then we're going to go through and we're going to identify all the pairs that show up in each of these. So we have a 2 up top, a 2 on bottom. Let's underline those. And we have an x up top and an x on bottom. Okay, here, our greatest common factor is just those pairs. So our greatest common factor, GCF, is equal to 2x. Let's try that again on another problem. Here's example 2. Go ahead and pause the screen and try this on your own if you are feeling ready. Otherwise, follow along with me. The first term is 9w squared. And we're going to expand that out. 9 can be factored into 3 times 3. And we get w times w. And 6 we can break down into 2 times 3 times w. Then we go ahead and we find those pairs that show up in each. So we have a 3 that shows up in each. We have a w that shows up in each. So our greatest common factor here is 3w. Okay, let's try this in one more example. Again, pause the screen if you need to work and try this, and note that we have 2 variables here. It doesn't change how we do the problem. We still want to expand everything out first and then identify which pairs show up in each term. So we can't split 5 down any further, so we'll just have 5. Then we'll have c times itself 7 times, 3, 4, 5, 6, 7. And d times itself twice, d times d. Then on the second one, we can break 10 down into 2 times 5 times c times c times c times d. So after we have everything expanded out, we can underline the pairs that show up together. So 5 shows up. We have 1c that shows up, 2 c's that show up, and 3 c's that show up. And we can underline one of our d's from each. Okay. And our greatest common factor here is just going to be a product of all of those. Our greatest common factor is going to be 5 c to the third power times d. Now, we're going to expand on this in examples 4 and 5, and we're going to skip 6 today. And write each polynomial in factored form by factoring out the greatest common factor. Okay. The first thing we're going to do is identify what the greatest common factor is, and then rewrite our expression here as a factored form. Okay. We have 12x squared, and so we're going to start off the problem exactly the same. We're going to break down 12 to its smallest possible numbers. So if I start this off and I go 2 times 6, that would technically work, but the surefire way to make sure we get our greatest common factor is to break it down even further. So let me clear this out, and let's go 2 times 2 times 3 because our 6 can break down into 2 times 3. Then times x times x. Okay, then we break down our second term, the 18x. Same thing, we could have 2 times 9, right? But then 9 is going to break down further into 3 and 3. So we'll have 2 times 3 times 3 times x. Okay, then we're going to identify our pairs just like we did before. So we have a 2 in each of these expressions. We have a 3 in each of these expressions. We have an x in each of these expressions. Okay. Our greatest common factor is going to be 2 times 3 times x. Or if we wanted to simplify that further, it's going to be 6x. Then what we want to do to write it in factored form is we want to place whatever's left over in parentheses. So notice how in our left term here, we have a 2 and an x left over. Those are going to go inside our parentheses. Plus, because our problem is separated by a plus sign, the 3 that's left over on the right. So our final answer here is going to be 6x times 2x plus 3. Now, if you were to go back and distribute in that 6x and multiply, you'll get what our original problem was, which is 12x squared plus 18x. Let's try this out on one more problem here. Again, pause the screen, try this yourself so you can have a good understanding and check it against mine. We are going to break down the 14 into 2 times 7. We can expand out the k. There's 4 of them. And we can break down the 6 into 2 times 3 and expand out the k as well. All right, then we identify what the common factors are. Okay. 2 and 2 show up in both. And we have a k and a k that show up in both, and then another pair of k's. So out in front, our greatest common factor is going to be 2k squared. And that leaves us with what we're going to write inside the parentheses. In our left term, it's 7k squared. And in our right term, it's simply 3. That sums up the examples that we're going to do today. Again, we're skipping example 6.